Hi, welcome to this tutorial in my series on permutations and combinations. And this is the first one in the series where I'm going to look at permutations. So what do we mean by permutations? Well, it's the number of ways that we can rearrange a set of items. For instance, let's say we've got two letters here, A and B. How many different ways can I rearrange these? Well, I could have AB, or I could swap the letters round and have BA. So what we end up with is two permutations or two arrangements. Now what happens if I had, say, three letters? Let's say A, a B and a C. How many ways could I rearrange these? Well, I could make a list of them. Well, I've done that, and you can see that we get 6. Now what happens if we had, say, 4 letters, A, B, C and D? How many different arrangements are there going to be for that? Well, it takes some time to list them all out, so we've got to have a better way of doing this. So let's go back to trying to see how this works. If we go to the two letters, we could think of this as something like a tree diagram. We could say that, okay, we've got our two letters. We'll do two sections, one for the first letter and one for the second letter. And when we choose our first letter, what could it be? Well, we have the two choices because it could be an A or a B. But as soon as we've chosen one of the letters, we've only got one choice left for each of them. If I choose an A, I can only go on to choose a B. Or if I choose a B first of all, then I can only go on to choose an A. And you can see here we've just got our two choices. Let's have a look at a tree diagram for this. What's it going to look like? Well, it's going to look something like this. As you can see, we've got three choices for the first letter, A, B or C. And for any one of those choices for the first letter, we've got two choices for the second. And as soon as we've made that second choice, we're only left with one choice for the third letter. And if you total these up, all these paths, you'll notice that we've got the 6 that we had here. But that 6 can be formed like this. We had 3 ways of choosing the first letter, and for every 3 ways we had 2 ways of choosing the next one. And then for any 2 that we chose here, we always had just one left over. And we have 3 times 2 times 1, which is 6, our 6 ways that we had here. If we do the same for this one up here, for the 2 arrangements, you can see that we had 2 choices for the first letter, and then for any of those 2 choices, we only had 1 for the second letter. 2 times 1 equaling 2, our answer here. Now when we do multiplication like this, 3 times 2 times 1 or 2 times 1, we often call it a factorial. A short way of writing 3 times 2 times 1 is called 3 factorial. A short way of writing 2 times 1 is called 2 factorial. If I had 5 factorial, that would be 5 times 4 times 3 times 2 times 1, whatever that works out to be. And you can often find these factorials on any scientific calculator. Search for one on yours and see if you can check out that 3 factorial gives you 6. Okay, if we've got something like this, then are we in a better position to work out how many arrangements we could make with A, B, C, D would be? Well, I'll leave it up to you just to work that out. Pause the video for a moment and come back and we'll just check the answer out. Okay, welcome back if you had a go. How did you get on with A, B, C, D then? How many different permutations are there? Well, if you drew a tree diagram, your tree diagram would have looked something like this. Now, I'm not expecting you to have drawn that tree diagram because it's horrendous basically. But can you see that the number of arrangements would have been 4 for the first letter, then 3, then for all of those 3 there would have been 2, and then 1. 4 by 3 by 2 by 1. 4 factorial in other words. And what does that come to? Well, it comes to 24. So I hope that you found out that the number of arrangements then was 24. Okay, so where is this taking us? Well, we should be able to realize that the number of permutations or arrangements of n different items is given by n factorial. Now I've got 3 questions here which I would really suggest you have a go at, especially number 3. So pause the video and come back when you want to check your answers and I'll run through them. Okay, welcome back if you had a go. Well, let's have a look at this first one. How many different ways can you arrange 6 people in a line? Well, essentially all we've got to do is just say, let those people have first names if you like, A, B, C, D, E and F, and then it resolves down to finding out how many different ways can we arrange 6 different letters. And the number of ways, if we just put an intro, the number of ways will be equal to 6 factorial, as we saw earlier. And what is 6 factorial? 6 times 5 times 4, 3, 2, 1. You'll get 720. Okay, number 2. How many different numbers can be formed from the digits 1, 2, 3, 4, 5, 6 and 7 if each digit is used only once? Well, it's exactly the same idea as what we have up here. Okay, it's not letters this time, it's just numbers, but the same thing applies. The number of ways, let's just put this in, the number of ways is going to be equal to 7 factorial. So 7 factorial comes out at 5040. Now what about this last question? How did you get on with this one? How many different car registration plates can be made then, consisting of the letters A, B and C and the numbers 1, 2, 3 and 4, where the 3 letters appear before the 4 numbers and each letter and number can only appear once in any registration plate? Well, what we've got here, just to recap, is that we've got our 3 letters must appear before the 4 numbers. And we can put, say, A, B and C in that order if you like, in the first 3, and we can have the numbers 1, 2, 3 and 4 in here. The number of different ways that we can get registration plates is not going to be 7 factorial. Now I don't know if you've made that mistake. It's not 7 factorial, and that's why you have to take special care over this one. What you have to do is look at how many different ways you can place the letters A, B and C in these 3 slots here. How many ways you can arrange them amongst themselves. Well, we know that will be 3 factorial. But any time that we arrange these letters amongst themselves, we can rearrange these numbers amongst themselves 4 factorial ways. So what we need to do is times by 4 factorial. And 3 factorial, 3 times 2 times 1 gives us 12, and we need to times it with 4 factorial, which comes to 24. 12 times 24 is 288. And notice then that this is not the same as 7 factorial. Okay, so you need to take care with questions like this, but I hope that's given you some idea of how to arrange n different items. It's always going to turn out to be n factorial. Okay? Well, thanks for listening, and I hope that's been of some use to you.